Hello my dear students, how are you all? Welcome to Deeksha Karnataka YouTube channel. I hope all of you are doing good. So again, I'm today back here with another session of KCET Masterstroke for mathematics. Chapter of discussion is going to be 3 geometry. So as you know, it's a one-shot session. Okay, we're going to complete all the concepts in the chapter. So be tuned for that. Okay, and also I've taken some questions to fill the gap between the problems and the concepts. Okay, so let's start the session without wasting any of our time. So what we have first is bacha, direction, cosines and direction ratios. So yes, you have learned this a little bit in the case of your vectors as well, but we'll see this over here as well, because actually this topic is part of your 3D only, but I taught you this in vectors as well, because questions at times can be asked by clubbing both the chapters together. Okay, so let's see what we have. Direction, cosines. So if you see, there's a vector written like this, vector PQ, okay, which is having an angle with the x-axis as alpha, with the y-axis as beta, and with the z-axis as gamma. I'll repeat myself. With x, please check, this is the angle, right? So alpha is the angle. Okay, with y, okay, we have the beta as the angle. With z, we have gamma as the angle. Okay, so this is called as, they are called as direction angles. Direction angles across x, y and z is going to be alpha, beta and gamma. Alpha, beta and gamma. Okay, now so once we get to know this value of the direction angle, we can find direction cosines very simply. Direction cosines, very simply, how much? Like this, please check. Cos alpha, cosine, that's cosine of or DC of the vector with x-axis. What next, bacha? Cos beta with the y-axis, and last one is going to be cos of gamma. Cos of gamma. Okay, so from there we also name this values to be with a variable. We have L equals to cos alpha. We write this as m, so cos beta, and next we write this as n, which is nothing but cos of gamma. Cos of gamma. The property, you know, right? We have the property L square plus m square plus n square equals to 1. Very important property. MCQ, the questions can be asked or frame on this property. So very important for us for the exam point of view. Okay, please understand this, very important. All right, sometimes they can also write in this format. Okay, so that's the same thing. Cos square alpha plus cos square beta plus cos square gamma equals to 1. Okay, same thing, nothing different, right? Because L is the value of cos alpha, value of L is cos alpha, value of M is cos beta, so it's the value of N as cos gamma. Okay, now so we can also find out a relation between our direction cosines and direction ratios. Okay, so understand one thing, ratios are nothing but, okay, means for a unit vector, no, if I'm writing, let's say if I know the value of L, M and N, I can write the vector bacha. Okay, how I write it, sir? L I cap, M J cap and N K cap. N K cap. Okay, it will represent a unit vector across if there is no magnitude involved, no, unit vector across the same vector direction sets. Okay, so understand this, very important. I think I taught you this as well in the vectors concept. Okay, now have a look over here. In the case of direction ratio, okay, what we can do is we have this formula. Okay, we have this. So what is going to be happening? There's a constant relation between them. Okay, means they're proportional actually. So L to A, they're proportional. L to A to M to B and N to C, where A, B and C are your direction ratios. Direction ratios. Okay, so please check here. We can write this, if I put this equal to, let's say, a value lambda, I can write this A as, okay, or 1 by lambda. If I'm writing over here 1 by lambda, I can write A as lambda L, please check, lambda M and C as lambda N. Okay, what I'm trying to say is, if I write here L by A equals to M by B equals to N by C equals to 1 by lambda, I can take, no, it's a constant only, right? Their proportional means there will be a constant value which is there, you know, equivalent to the ratio will be equivalent to. Okay, so let's call that value to be 1 by lambda. If you do that, cross multiply this first two, what are you gonna get? A equals to lambda L. Same way, the second and the last, you get B equals to lambda M, and so is the last C equals to lambda N. Okay, so this is the value. Please check here for some non-zero real number lambda. Non-zero real number lambda. Chaliye. Okay, what next we have, sir? Let's have a look. Okay, so before I move on to our one sort of 3D, okay, I have an announcement to make for all of you. As you already know, we are here with your Abhyas KCET test series. If you're somebody who has already enrolled into it, if you're somebody who has taken the free trial and planning to purchase it later after examination, good for you. But if you're somebody who has missed out on this chance, bacha, please do not avoid this. It's a very important tool, very important a part of your arsenal going into KCET examination. Okay, telling you why. Because first of all, at Deeksha, you can see the results have been commendable for the last 25 years. Okay, we are here to help students, okay, to achieve a great rank in their preparation journey for any KCET examination that year. They're writing whether this is previous year, year before that. We've been there like that. Okay, so I want you to be part of this journey as well. Okay, if you are not sure right now, do one thing: take the free trial. Is it there, sir? Yes, it's there. You can take a free trial today at 0 rupees. Just enroll yourself. Okay, you don't have to pay anything, and you get 4-part tests free. Okay, you get one for physics, chemistry, biology, and mathematics. Each paper, as you know, as per standards, you have 60 questions in each paper. Okay, and then you get from us, of course, you're gonna get question paper. You're gonna get the solution in the PDF format, also solution in the video format by each subject faculty. For maths, I'm going to give the solution. So please enroll right now at 0 rupees for the free trial. Okay, now one more thing. After the free trial, from the 17th of March, why 17th of March? Because of your boards. Okay, from 17th of March, you'll have to start 31 paid tests. Okay, so in that which you have full syllabus and chapter wise test. Okay, what else is there? Detailed video solutions and analysis, chapter wise one-shot revision videos, chapter wise insights for last 5 years for KCET papers. Okay, so make sure you are somebody who has taken this. Very important to because this exam is about solving questions in the examination, right? So how can you do that? By practicing more and more problems. There comes the KCET test series, very, very handy. Okay, so please make sure that you are somebody who has taken it. The price right now going on at $14.99. Okay, so make sure that you are somebody who has purchased this Abhyas KCET test series. Let's move on now to your session. Direction cosines of a line passing through 2 points. DC of a line passing through 2 points. What happens, bacha? Actually, what you're going to do first, you're going to find the direction ratio in this case. Whenever you find 2 points, something like that, no? First step is to find the direction ratio, sir. First step is to find the direction ratio. Then we'll use the relation between the ratio and the cosines. I'll again repeat the relation. So first step is to find the direction ratio. Second step is to find, use the relation between direction ratio and direction cosines. Okay, to find what, bacha? To find the value of DC. Please check. So what is this, sir? x2 minus x1, y2 minus y1, z2 minus z1. This is nothing but your direction ratios. Please check. So d arc of the line segment joining the points, they have given the coordinate, right? x1, y1, z1, and x2, y2, z2 is given by this. Either you can write x2 minus x1 or x1 minus x2. Both is okay. Pick one. No, none of the case. Okay, doesn't matter. Either you write x2 minus x1 or x1 minus x2. Both will be the value of your dr. From there, what are you gonna get? Let's call this value to be a, b, c. Let's call this to be a, b, and c. Okay. What do you do next? Now you divide this by pq, pq, pq. What is pq, sir? Simply square of. Please check a, b, and c sum. Isn't this actually A, sir? Isn't this actually B, sir? Isn't this actually C, sir? Please check. A was x2 minus x1, B was y2 minus y1, and C was z2 minus z1. So you're gonna take this value. What is this going to be, sir? Please check. If I have to rewrite this, so your L will become over here. I've taken this value as A, no? So A upon the same thing, root of A square plus b square plus c square. And same way you can write this for m with b in the numerator and same result coming in the denominator, and same thing you're going to do for n, writing this as c upon the same square of a square, the same square sum of a square, b square, and c square in the denominator. Is that clear? Okay, this is the relation between the DC, the direction cosines L, and the ratios a, b, c. Is it clear? First step is to find what? Direction ratios. Next you use the relation. You get the result very simply. Let's move on now. A simple concept, not difficult at all. In the knowledge hub today we have, please have a look. If okay, I've done this already. Check here, L square plus m square plus n square is equal to 1, but not necessarily this will be equal to 1 as well, until unless they are both equal. Whenever we have direction ratio and cosines equal to each other, then of course the property will be valid. Otherwise you cannot say that a square plus b square plus c square will be equal to 1. Cannot say that. Okay, this is okay, this is all right. Okay, so what next now? Direction cosines of a directed line are unique, but direction ratios are not unique, of course, right? Because there's a proportionality, no? Means I can have a factor of 2 or 3. Remember this? L by A equals to M by B equals to N by C. No, I can have, let's say over here 1 by 2. I can also have 1 by 3 like that, no? So I can keep multiplying, a constant which will change its value. That's why direction ratios are not unique. That's why direction ratios over here, direction ratios are not unique. Whereas in the case of L, always unique, bacha. Why unique, sir? Please think about it. Alpha, beta, gamma will be unique, no, in the nature. Angle made by the vector with respect to your x-axis, y-axis, z-axis cannot change, right? For any given vector, it means alpha, beta, gamma will be a constant. Okay, providing that cos alpha, cos beta, cos gamma will also be unique. That's why DC is unique, but DR is not. That's why, okay, direction cosines of a line can always be called, okay, means we can call the cosines to be also as ratios. Means it's simply terminology understanding. This can be called this, but not vice versa, not always. Okay, means direction cosines can always be called as direction ratios, but not direction ratios ABC of a line are its direction cosines if only if this is valid, bacha. I told you, whenever A equals to L, B equals to M, and C equals to N, then only we get bacha A square plus B square plus C square equals to 1. So only in that case we can call direction ratios to be equal to direction cosines. Make sense? Okay. But we have, since x, y and z axis pass through the origin and have direction cosines as, for x axis bacha, 0, 90, 90 na, so it will become 1, 0, 0. Correct na? Cos 0 is 1, cos 90 is 0, cos 90 is again 0. That's why 1, 0, 0. For x axis, for y we have 0, 1, 0, right? 90, 0 and 90. So cos 90 is 0. It's going to be what, bacha? Going to be cos 0, so 1, again 0. Over here what we have for z axis, 0, 0 and 1. Okay, so they are very simple, bacha. Yes, they are very simple. Yes, they are very simple. But if you don't remember this simple concept, no, you lose marks in your MCQs. Okay, so very important to know this. Okay, so then the equations will become, bacha, for x axis you'll have y0 and z0, because x can be anything, right? For y axis, x0 and z0. For z axis we have x0 and y0. Very, very, very important. I've taken a question on this. Okay, you'll see. Let's move on now. Equation of a line through a given point and parallel to a given vector. Again, we have done the derivations. We have two forms. One is called as the vector, other is called as Cartesian form. Remember the vector form, bacha? Vector form was, if you remember, r equals to a vector plus lambda times of b vector. Okay, and in the case of Cartesian form, please check what we have. X minus x1. What is x1, bacha? The point, x coordinate of the point where it is passing from. So a point you can see, no? So this is x1 is nothing but the x coordinate of the point A. Is that clear? Okay. So x minus x1, y minus y1 and z minus z1. What is element, sir? The dr of the vector B actually. What is element, sir? This is nothing but dr of vector B. They have given here, right? Please check. In this case they have mentioned this as DC. As I said, DC can be called as dr also, right? That's why they have mentioned it like this. Okay, so element. Parametric form, equation of the line through x1, y1, z1 having direction ratios Lmn, okay, given like this, x by x1. So basically involving a parameter over here, r, a constant over here, r. Same thing, just writing a constant over here. If you do that, what are you gonna get? Please check. You can multiply L to r. I'll show you over here for the first one. I'm writing x in terms of the parameter. This is equal to r, right? So please simplify this. You're gonna get x minus x1 equals to L times of r. From here you get x equals to x1 plus lr. x1 plus lr. Please check. This is done. Same way, y1 plus mr and z1 plus nr. Okay, writing the x in terms of what do you call your parameter r. Moving on. First question that we have to solve. Let's see. Find the Cartesian equation of the line through a 1 minus 2 and 3, and the parallel to the line this. Okay, great bacha. From here what we see, please check. From here what we see this is nothing but 1, right? Nothing but 1, right? So I have this ratios as, Acha, one thing, just check once the values that you have for what do you call for the coefficient of x, y, z should always be 1. I'm asking you this all the time when I'm teaching this concept. Whenever you have the coefficient value of x as 1, then it's okay, no change. Otherwise you have to make that to be equal to 1. Okay, to why, when bacha, when we are considering the values of your direction ratios. So a value is nothing but 3, b value is nothing but -6, and c value is nothing but 1. Now write this. You'll get here x minus 1 upon 3, y minus of -2 upon -6. Okay, and I get here, please check, z, nothing is there, no, z minus 3 is there upon 1. Okay, upon 1. Okay, so if you check this carefully, you're gonna get x minus 1 upon 3, y plus 2 upon -6. Okay, and z equal to 3 from there. So option number C is correct. Correct now? L equal to 1, right? If I take this one on this side, it will become z equal to 3 only, no? Okay. So this is done. Question number 1 is done. Let's move on now. Angle between two lines. Okay, we can find this with the help of your dot product also. This is simpler. We can also use the feature of cross product as well. Okay, so please check. So we know the dot product. We know the dot product is given as like this. You remember this? A dot B equals to vector A modulus and vector B modulus and cos theta. So we want to find the angle, right? So bring this constants on this side. What do you get? A dot P divided by A B. Okay, we have here cos theta. I can keep this theta on this side and apply a cos inverse on this side. Please check. Second theta equals to cos inverse of A dot B upon modulus of A and B. Same things written over here. Please check. Okay, so they have given the vector in the form of their rectangular components. So L1 I cap, M1 J cap, and N1 K cap. So is the vector beta is also given like that. So what you get for and also they have given a chart. Please check here. They have given this as unit vectors. It means mod of alpha will be 1, mod of beta will also be 1. Okay, so if you check out this denominator, what will happen over here? Excuse me, it becomes equal to 1 into 1. Na 1 into 1. Hence we have only A dot B left. If you multiply dot of this, L1 into L2, why not other bacha? Because I into J will be 0, I into K will also be 0. Dot product feature, the feature of the dot product, you cannot take I dot with J or K. That will be coming as 0 only, because cos 90 will make it 0. You know that, right? Same way M1J, M2J will become M1, M2, N1K and N2K will become N1, N2. Why, sir? Because J dot J will become bachas JJ cos 0 is 1. Okay, that's why there's no J left. Chali. So this is your answer. Let's see from the point of view of cross product, bacha. This is from the point of view of cross product. Cross product. This also, you remember, we used to write like this. Vector A cross vector B was given as mod of vector A, mod of vector B, and we have, of course, in this case, sine theta. Okay, from sine theta. So what are we gonna do? Please check here. We're gonna get theta as sine inverse of, remember this, A cross B upon mod of A times mod of B. Mod of A times mod of B. Okay, so A cross B, if you're finding, how do you find bacha? Please check here. You have to find the determinant of this. L1, M1, N1 is the vector number 1. Okay, so alpha vector, this is the beta vector. You find the determinant will come like this. Okay, so find this A cross B, bacha. So this will be value of A cross B modulus square of this value, square of this value, square of this value, taken in sum inside the root. You get the modulus like this. Clear? And we know this already, that this value is nothing but, what is this, sir? 1 into 1. That's why I ignored. I can simply write this as the final answer and apply theta. So basically sine inverse on this value. Sine inverse of this value will be your answer. I'll repeat myself. Sine inverse of this value will be your answer. Okay, looks complicated over here, but it will be easier when you see the questions. Okay, chaliye. Conditions for perpendicularity. Of course, bacha, what will happen whenever you see perpendicular? No, go with cos 90 because it will come 0, right? I'm telling you again. Whenever you see perpendicular, go with the dot product result. There are two results for angle between two vectors. I'll repeat myself. There are two results for angle between two vectors. One is the dot product result, other is cross product result. Okay, so we use dot product result whenever we are dealing with perpendicular lines. How come, sir? Cos 90 becomes 0. But in the case of parallel lines, we use sin theta or the dot product or the cross product. Okay, because sin 0 is nothing but 0 only, right? Please check. So for case of perpendicularity, what we are using over here? Please check here. We are using, sir, cos theta is 0 from this feature of over here. Cos 90 will be 0. You write this equal to 0 when the theta is 90 degree. Got it? Same way over here. If theta is 0, we write this as, when theta is 0 or pi, we write this sin theta as 0. This case for the parallelism. Okay, please check here. So from here we get the result as, in the case of with respect to your DC, or you can say with respect to your direction ratio, remains same in the case L1 L2 M1 M2 N1 N2. Acha, one more thing over here, this relation is given in terms of DC. Please check. But can I say the same thing for DR also? Yes, we can. I'll tell you why. Sir, I can ask you a question. A student can ask me a question thinking that, sir, this relation came when you took DC, no? Because in the case of DR, what will happen? You'll have a denominator. Let's go back. You're saying that if in the case of DR, if we are talking about, it will not be, no, sir, 1 1. In case of DR, if I'm taking, it will not be 1 1, sir, because you said L1 M1 N1 is the is used only when you're talking about the unit vector. Okay. So if I am taking, instead of this, if I'm taking A1, B1 and C1, if I'm taking A1, B1 and C1, okay, what will happen? You'll have A1, A2 plus B1, B2 plus C1, C2, na, sir. But the denominator will also be there, sir. You'll have two results like this, A1 square plus B1 square plus C1 square. Same way again you'll have A2 square plus B2 square plus C2 square. So basically, as your question might be, sir, there is a denominator. Then how come that is not there? But because if you put this value equal to 0, for cos 90 you put it equal to 0, these are two non-zero values, no? These two can never be 0. Can multiply on this side or not? Yes, you can. If you do that, what are you going to get? What are you going to get? If you multiply this denominator on this side, what are you going to get? 0 only, right? So result will become same thing. What are you going to become? Please check. You will have the same result as A1 A2 plus B1 B2 plus C1 C2 equals to 0. Whether, that's what I'm saying, whether you take direction ratio or direction cosines, you'll have the same result. Okay, same way. Let's move on now to parallelism. When theta is 0, sin theta is equals to 0. Same concept will repeat again. L1 by L2, M1 by M2 and N1 by N2 becomes equals to a constant, can be taken as K. Okay, same goes with your, you can apply this. This is concept given for DC also, and same can be repeated for DR as well. Okay, I hope this makes sense to you. Let's move on now. Angle between two lines whose direction ratios are given. Please check. Same concept here, bacha. Right? Especially I took this case as no. This is the answer, right? The answer is this, bacha, actually. But for the case of perpendicularity and for the parallelism, the result will remain same. I can repeat the same result in terms of DR. But in this case, when this is not parallel or perpendicular, then we have to use, of course, the denominator. I already proved this for you. I hope you remember this. Correct or not? I proved it, this part, no? A1 square plus B1 square plus C1 square. Okay, times of A2 square plus B2 square plus C2 square. Okay, please check this out. Got it? Let's move on now. Alright, so corollary 1, condition of perpendicularity. What will happen, bacha? As I said, same thing will repeat. Have a look. Over here also same thing will come. Please check. Done? Same thing will come, bacha. Okay? Same thing. I already explained you those two parts. Okay? Equation of the line passing through a given point and perpendicular to given lines. So they have given two lines to us, A1 plus lambda B1 and A2 plus mu B2. Okay? They are saying that passing through the point, okay, passing through the given point and perpendicular to these two vectors. So let's say, bacha, passing through the point, this is the vector A. Okay? Passing through the point with the vector A. So the point where it is passing from, the points vector, position vector is nothing but vector A. That points position vector is the vector A. So that part is clear, na? That part is clear. So it means one thing is for sure, we know that this is okay. This is okay. but we don't know the direction sense. But they're saying that perpendicular to both of them, perpendicular to this and this, what are you going to do then? Simply take sir B1 cross B2. Correct, huh? What are they saying? The line, let's say the line is called as line L. So the line L is actually perpendicular to the line, this one, let's call this line to be L1, and this to be, let's say, line L2. So basically they are saying that line L is perpendicular to both the lines. How can you get the bacha? Basically, what do you call? You take the perpendicular of these two, and how do you find that? By help of cross product. So simply sir, please check here, B1 cross B2 you're gonna find, and of course there will be a parameter, a constant t involved here. So we write here a plus the constant t. We use lambda in the cases, but over here I'm taking t and write this as B1 cross B2. I hope you understand this result very clearly. Why this B1 cross B2 bacha? Because they are saying that perpendicular to the lines this and this. How do you find perpendicular of these lines? Of course by multiplying or by using cross product bacha. Clear na? Okay. Find the angle between the pair of lines. What is the answer bacha? 0 sir. Angle is theta equals to 0. How do you find that sir? Please check here. The lines are actually parallel na. Have a look. 1 to 2 sir, what I get? 1 to minus 2. What I get over here? Please check 2 to minus 4. Excuse me. Over here I get minus 2 to plus 4. What is the answer going to be? Minus 1 actually. Minus, no, not minus 1. Minus 1 by 2, no? Minus 1 by 2. Minus 1 by 2. Okay, I hope this is clear. If you want, you can find this result as well in this format. Right here. Cos theta equals to B1 vector dot B2 vector divided by mod of B1 vector times mod of B2 vector. Find the result over here. What are you getting? Please check. You're getting this result as, have a look, dot of this vector will become 1 into 2 is going to be simply, of course I have a minus sign, no? Right here with the minus sign I get here 1. Okay, 1 into minus 2, no? 1 into, have a look, 1 into minus 2, right? Yeah. What next? I have 2 into minus 4, right? Plus 2 into minus 4, right? Okay, and I get minus 2 into plus 4. Why the sign bacha? Please check here. I have minus 2 over here, I have minus 4 over here, and I have plus 4 over here, because the result has plus mu into it. You remember the formula? Vector form has what is write this as a plus mu times of whatever it is, vector b. Okay, that's why. So I'm writing this negative sign inside, not a problem, no? Divided by, have a look, what I get now. First vector is square, so 1 plus 2 square is 4, plus again Masterstroke square is going to be 4 only. Second root will be bacha, please check, 2 square, so Masterstroke square is going to be 4 again. You'll have this again as 16 and 16. Please check the result in the numerator. We get here minus 2, minus 2, minus 8 and minus 8. Alright, they have a modulus in this. What I'm gonna get? Root of 9 and root of 36. Please check. 32 plus 4 is 36. Okay, so my result will be nothing but 18 in the numerator. Please check here. 8 plus 8 is 16, plus 2 is 18. There's a negative sign, but modulus makes it positive. So plus 18 divided by 3 is the root of 9 and 6 is the root of, so cancels. Answer is 1. I'm getting here cos theta equals to 1, hence theta equals to 0 degrees. Please check. If you want, you can do all the process or simply know this, because if they're proportional means they have to be parallel. Remember A1 by A2, B1 by B2, C1 by C2. So I already wrote this, means they are parallel. Please check. That you can write from here also. Parallel lines. Is that clear? Okay, let's move on now. The angle between the lines passing through the points, okay, given like this. We have to find the angle, but before that we have to find what's the direction ratios. We have to find the direction ratios. Let's find for the line L1. Okay, what are you gonna do then? For line L1, 4 minus 8 will be minus 4 I cap. 6 minus 2 will be plus 2. Please check here. Plus 2 J cap and minus 7 K cap. Okay. What about line L2, bacha? This is line L2. Okay. This is lines. These are the lines. Okay. All right, we write here minus 9 minus 3 becomes 6. Okay, minus 9 minus 3, no, so actually minus 6 I cap, minus 2 minus 1, so minus 3 j cap. All right, and I get here last one 4 minus 2, so plus 2 k cap. The formula remains same. Cos theta will be, please check, modulus of product of these two, so 24, these two minus 6, okay, and minus 14, right? Something is missing, I think. 6 minus 2 is 4, sir, over here, please check. So it'll be 12, bacha. It'll be 12. 1 second. I made a mistake in calculation. I'm gonna change that. Have a look. Okay, I think I have changed it. So what I'm doing is 6 minus 2 will be 4. No, I took it as 2 actually. So it will be 4 j cap. Multiply 4 into 3 will be minus 12. 7 into 2 will be 14 with a negative sign, divided by, have a look, modulus of two vectors that we have, 16 plus 16 plus what we have, 49. Na? 4 square is 16, again 16, again we have 7 square as 49. Multiply this with, have a look, 6 square is 36 plus 9 and plus 4. Plus 4. Please check here. The numerator is coming out to be 24 minus 26, right? So it will become minus 2 the modulus. This is minus 26, no? So it will become minus 2 the modulus. Please check. Divided by what I have. 16 plus 16 is 32. 32 plus 49. So 79, 81, right? So root of 81 dot with 49. 49. How much is the answer? 2 upon, I get this as 9 into 7, right? So my answer is coming out as, please check, cos theta is nothing but from here 2 upon 63. Okay, so theta will become a cos inverse of 2 upon 63. Please check. Option suitable is over here A. Option A is correct. Question number 3 is done. Option A is correct. Have a look. Done. Move on now. Write the equation of the straight line through the point given like that. So this is okay. X minus alpha, y minus beta, okay, and we have z minus gamma. All right. Parallel to z axis. Parallel to z axis means what? You can write the drs for this. It will become 0, 0 and 1. The drs. Okay. So right here 1, 0 and 0. So answer would be your x minus alpha, y minus beta and gamma. Okay, I think there's a mistake over here, bacha. Please check. I think they have the two options same. So please make this change. You can pick any one of them. It's a mistake from my side. Okay. So let me make this as plus. Okay. We'll just make the different option. They're both the same options, right? Alpha, x minus alpha, y minus beta and z minus gamma by 1, 1, right? So they're both the same options. I'm picking the option number B, making option C as z plus gamma upon 1, just to make this incorrect. Okay, no reason, but the right answer, you know, this is the right answer, right? This is the correct answer. So option B, I'm taking it right. Please understand this. Okay, B and C are same option, that's why I made this change. I hope this is okay. Z plus gamma I've written, z plus gamma upon 1. Moving on now, the last concept that we have to learn today. Shortest distance between two skew lines is given this by this property. The cross product of the lines where it is parallel to. So if I write vector, let's say I like to write the L1 line with this relation. R is given as A1 plus lambda times of B1 vector. Same I can write bacha for the line L2 with the relation R equals to A2 vector plus lambda B2, lambda times B2, or they've given here with mu. Okay, I can't take the same, no, so let's just take this as mu over here. Okay, I'll take this with mu over here, not a problem. So if I do that, okay, so basically check here, the line L1 is parallel to B1, right, and the line L2 is parallel to B2, right? So you're going to take the cross product of those two vectors. So B1 cross B2, B1 cross B2, dot with A2 minus A1, dot with A2 minus A1 divided by, of course, the modulus of B1 cross B2, B1 cross B2. Please check. Done, na? Right? Okay, this is the formula for your shortest distance. How to find B1 cross B2? The same result we have. To find B1 cross B2, we know this. So first you're going to write what? Please remember, you'll have I, J and k, and you're gonna write the vectors b1 over here, the dr's of vector b1 over here. What are you gonna write? Dr's of vector b2, okay, and then simplify the determinant of this value to get the vector form of this, and then find the modulus for the denominator. Numerator will be the same result. Okay, so what is the distance between two parallel lines? How much is that going to be, bacha? Of course, parallel means, bacha, b1 b2 will be same, no? In that case, if you take parallel means, understand this, you will not have b1 b2, you will have same vector b. Okay, then what happens is simply the result will remain like this: b cross a2 minus a1 upon b, mod of b. Please check, this is the formula. You will not have two vectors anymore because the parallel, right? It means b you're gonna take. Okay, you're gonna take b simply. Okay, when they are intersecting, what will happen? Equal to 0. Intersecting in nature means what is the shortest distance? 0, right? Okay, please check. Same result you'll write. This will be a value, you know, you can take on the other side. So b1 cross b2 times dot of a2 minus a1 will be coming as 0. Please check. Okay, Cartesian form if you're writing, same thing. This will turn out to be equal to 0. Alright, please check. Okay, this is nothing but what, bacha? A2 minus a1, no? What is this part, bacha? What's the first one? A2 minus a1, sir. What is this part, bacha? b1. What is this part, sir? b2. Right? Yeah, b1, b2. What is this, sir? A2 minus a1. This also is an important formula. Please remember this. In my regular sessions that I was doing in 60 or 60 KCET series, I have done questions on this. Remember? Chali. Let's move on now. The question number 5 and the last question of the day. We'll complete this and we'll complete our session today. The shortest distance between the lines given like this will be how much, sir? Will be how much, sir? Let's solve it. So we're gonna use this Cartesian form only. So how do you find it, sir? Please check. So I can find, why not we can use, okay, let me do it in the form of vector. It'll be easier for us. Okay, so if I'm writing the first, let's say I'm writing this from here, writing a1 first, the point coordinate vector, you get 0 I cap plus 0 j cap plus a k cap. Okay, same way from here, if I'm writing my vector a2, I want to get this as, please check. So vector a2 will turn out to be 0 I cap, and we have plus 0 j cap, and we'll have minus, in this case, minus a k cap, minus a k cap. Is that okay? Chaliye. So what we are finding now? A2 minus a1. A2 minus a1. It will turn out to be minus 2a k cap. Correct, na? Minus 2a k cap. Have a look. Great, sir. What next we have is simply we have to find b1 also. So what is b1, bacha? Vector b1, if you look at, you're gonna have this as m1 I cap plus j cap. Okay, same way you'll have b2 as, have a look, m2 I cap, and you have plus j cap, of course, plus j cap, m2 I cap plus j cap. Okay, once that is done, let's can find this value of b1 cross b2 vector. Have a look. 1 second. Have a look. If I'm doing with m1 I cap with m2 I cap, that is 0, na? Right? Because I cross I will be 0, bacha. So I can't do that. Understand this? m1 I cap into m2 I cap, you cannot multiply. It will be 0 because I cross I will be 0. Okay. What about next, bacha? I can multiply m1 I cap with j cap. So right here, m1 I cross j. I cross j. Okay. What next we have? Have a look. We have over here. Check this out. Now first I multiply this with the both the terms. m1 I cap into m2 I cap will be 0, and m1 I cap into j cap will be m1 I cross j. m1 I cross j. Next what, bacha? We're gonna multiply j with this thing. If you multiply j with m2 I2, what are you gonna get? Plus m2 times of j cross I. J cross I. Multiplying this with this, right? Multiplying, please check here, j with this. So m2 cross I. Okay, done. Let's move on now. Same way we're gonna do j with j. It'll be again 0 only. J with j is 0, right? Because cos sine 0 will be 0 only. What I'm getting over here, please check here. I'm getting m1. I cross j is nothing but, bacha, k cap, and we get here plus m2, and j cross I will be minus k cap. Minus k cap. Okay. Remember this, I cross j. So I, j and k. Go I cross j, you're gonna result with k. And if you go j cross I, if you go j cross I, you're gonna get what, bacha? Minus k, na? You're gonna get minus k, right? That's why it's minus k. Take k common, what are you gonna get? m1 minus m2 times of k cap, right? I'm taking the k common, okay? This is the value of, please check, b1 cross b2. b1 cross b2, okay? Can you find the modulus of this, bacha? Can you find the modulus of this? So you find the modulus of this will become b1 cross b2 mod is nothing but, have a look, root of m1 minus m2 square. How much is that? Simply m1 minus m2. Simply m1 minus m2. Because we don't have I cap and j cap over here. Okay. Now we'll use the formula. What is the formula for distance? We have b1 cross b2 vector form dot with a2 minus a1 divided by mod of b1 cross b2, right? Okay, please check. One change I have to make over here. Mod is there only in the numerator, bacha. Okay, let's solve this now. We have this value as m1 minus m2 k cap, right? Dot with, excuse me, we have this as minus 2a k cap. So right here, minus 2a k cap, okay, divided by this we got already m1 minus m2. Remember this, mod of b1 cross b2 came as m1 minus m2, okay? So if you multiply them, what are you gonna get? Please check here. Dot will become, k dot k will be again 1, right? And we'll have over here minus 2a m1 minus m2, okay, divided by, of course there's a modulus over here, and m1 minus m2, okay? If you apply the mod, this will make this minus positive. You're gonna get this as 2a m1 minus m2 upon m1 minus m2. Cancel this and this. What I get? Simply result as 2a, which is equal to nothing but my sorted distance d. So answer is coming as option number C. Option number C. Please have a look. Is that clear? Have a look. This is clear, right? Okay. So this is done, bacha. This is done. The session is complete. I hope you had fun. So I have given all the information that you need from this chapter. If I missed something, let me know in the comment section. If you want something else from me, you again let me know in the comment section. So just keep working hard, keep doing your work. Anything you'll need from myself, again just ask for it. I'll try to deliver that in the best way possible, okay, from best of my abilities. Right now I'll just take your leave. Keep working hard, keep smiling. See you again very soon. Till then, take care. Bye bye.